So 1 radian represents 1 radius of length around the circle. Okay, and if this is a unit 1 centimeter, for example, that would represent 1 centimeter around the circle. Now, if we scale this to any radius, well, that's still going to hold true. That turn will be the same regardless of how big that circle is. So this is how we're going to define a radian. Radian is 1 radius, the number of radiuses that we can put along the arc of that circle. So our radian measurements is we have our 2 pi, so it's going to be arc length to 2 pi r is going to be our fraction of our circle, and this fraction is what we are going to be using. Okay, so we are going to be using this arc length to 2 pi r ratio essentially to do a lot of calculations, and we often will talk about arc length. Okay, if we want to figure out the arc length, the nice thing is the arc length is the radius of the number of radiuses around the edge of the circle. Okay, so let's do some basic conversions. Okay, we don't want to make it too complicated. Let's just do some basic conversions. And when we talk about radians to degrees, we're going to just use our conversion factor. We know that this ratio holds true. Okay, this is one's probably easier. Okay, we're just going to use half circle instead of relating the whole degrees to the whole circle. So I'm going to say that 180 radians is equal to, 180 degrees is equal to pi radians. So we can do this. We can set up a ratio if we want. Degrees to radians is equal to degrees to radians. Okay, and we can then solve for that x. Okay, so in this case, x equals, I need a calculator here. It's about 0.6 radians if I'm not mistaken. So I cross multiply, I get 34 divided by 180 and then times by pi. Okay, so it's 0.593. Okay, so we're just going to round that to 2 decimals. We're going to say that's 0.59 radians. Now I'm going to write radians down for now, but radians actually have no units. Okay, so this is, when you see rad or radians, that means radians, but again, if it doesn't have any unit, radians technically have no units. Now, it's probably easier to do this calculation. Now, maybe I'll do it in the next one. When you do using your times divide strategy, okay, I have 330 degrees. I need to get rid of the degrees, so I'm going to multiply it with the degrees on bottom. There's my ratio, radians on top, degrees on bottom, degrees cancel out, so I should be left with radians. So here I'm going to go 330 times pi divided by 180. Okay, so it's going to give me 5.76 radians. I'm just going to write it over here. It's about 5.76 radians. Okay, now because 330 and 180 actually share common factors, and 330 is a special angle, we're going to actually do this in terms of exact values of pi. So I'm going to divide by, looks like 30 here, so I'm going to get 11 over 6 pi. Okay, and this is the exact form that we want. And for special angles, we're going to use the pi values. So here, converting 1 radian into degrees, I'm going to go 1 radian. If I'm going to multiply, I need my radians on bottom to make the radians cancel out. And then I'm going to have degrees left over. So 180 divided by pi is about 57.3 degrees. Okay, so there's our conversion factor for 1 radian. It's about 57.3 degrees. So same thing here, 4.56 radians. I'm going to use my multiplying ratio. I'm going to put radians on bottom and degrees on top. That way I'm going to get degrees as my answer. So 4.56 times 180 divided by pi, I get 261.3. 261.3. And again, make sure you know what units you're dealing with. It's very important to keep track of the units that you're dealing with. So 20 degrees here, 20 degrees, I'm going to times by 180 degrees on the bottom to cancel out. And then I'm going to simplify. Now this is not a special angle, so I'm going to convert it to decimal, although you could find common factors and put it into fraction, but special angles, since it's not a special angle, we're not going to bother doing that. So here I'm going to get 0.34, round that to 0.35 radians. Okay, and then lastly, 0.23 radians. Okay, so it's 23% of 1 radian, so it's probably going to be about quarter, about 15. It looks like a little under 15 degrees. So let's go times by, again, the degrees now on top, the radians on bottom so that they cancel out. Okay, that's a radian here. Cancel those out. 0.23 times 180 divided by pi gives us 13.17, so I'm going to round that to 13.2 degrees. Okay.